Hello, in this chapter, moving charge and magnet. First is Oersted experiment. In Oersted experiment, if this is the arrangement here, AB wire connect a closed circuit and this magnetic compass needle is placed that it is in the direction of AB wire. After closing the key, current is flowing from A to B and north pole is deflecting towards west. In the second figure, current in opposite direction flowing from B to A, the north pole is deflecting towards east. So, by Oersted experiment, we can say current is produced of magnetic field which interacted with the compass needle, a magnet, a small magnet. Due to the interaction, there is a deflection in the north pole. Now we can find out the direction of deflection of a magnet by either Snow rule or swimming rule. First, Snow rule. If current is flowing from south to north, the north pole will be deflected towards west, otherwise east. Or by swimming rule here is, imagine we swim in such a way that the current is entering through our feet and exiting through our head. The north pole always deflects towards our left hand. In this figure also, current is entering through our feet means A to B, exiting through our head. So, north pole is deflecting towards our left hand means towards west. In this, current is flowing from B to A, entering through feet and exiting through head. The north pole is deflecting towards our left hand means east. So, conclusion here, the current or the moving charge produces magnetic field. Unit of magnetic field is Tesla in Ampere system and Gauss in CGS unit or system. The relation between the Tesla and the Gauss, 1 Tesla is equal to 10 to the power 4 Gauss. Now, force on moving charge in external magnetic field. One magnetic field, this is the external magnetic field, and one producing by the moving charge. Because of the interaction there are between the two magnetic fields, it is force acting on this moving charge, and this is the force is directly proportional to charge and directly proportional to the perpendicular component of velocity vector v sin theta and proportional to magnetic field. If we combine here, force is directly proportional to qvb sin theta and proportionality constant k, the value of k is 1. So, the force formula here is qvb sin theta. In vector notation, F vector is equal to Q bracket V cross B, the cross product of velocity vector and the magnetic field vector. This is sometimes called full Lorentz force. And direction of the force can be found by either by this right hand screw rule or Fleming's left hand rule. In Fleming's left hand rule, if we stretch the thumb, forefinger and the middle finger perpendicularly, then this thumb indicates the force, forefinger magnetic field and the middle finger current. It is sometimes called F means father, M magnetic field means mother, and C current means child. Father, mother, child. This way, by using the Fleming left hand rule, we can find out the force on moving charge in external magnetic field. Here, in this formula, F equal to qvb sin theta. If theta is 0 degree or 180 degree, then force will become 0. Because the value of sin 0 is 0, sin 180 is also 0. So, there is no force, there is no acceleration. This moving charge will move without any deflection in the external magnetic field because there is no force. Suppose here case 2, when theta is equal to 90 degree, means velocity vector is perpendicular to the magnetic field. In this case, this force will be maximum qvb sin 90, sin 90 is 1, so this is the maximum value. By using this left hand rule, suppose it is moving in this direction, v velocity, so this is the positive charge, so this is the current here, and magnetic field is inward by cross field, so the force is towards acting in the anti-clockwise direction, so it will rotate in the circle in anti-clockwise sense. If it is negative charge, current will be in opposite direction. So the force, because of this force, will move in the clockwise direction. Positive charge will move here in this case in anti-clock, and electron negative charge will move circular motion in clockwise direction by using the left hand rule. So here, if it is moving in circular path, centrifugal force will be there. So magnetic force and the centrifugal force both are equal. Equating these two, force is Q will be sin 91 and centrifugal will be mv square upon r. So this way we cancel out and we can find out the radius given by the formula mv upon qb by equation 1. And the time period is distance to pi r upon speed v, putting the value of radius here from equation 1 here. So v cancel out, it is 2 pi m upon qb. This time period and the reciprocal frequency is independent of velocity. Frequency also the reciprocal of this time period. T is independent of speed, frequency also independent of speed. Now case 3. When this velocity vector of charged particle is making an angle theta which is other than 0 degree, 180 degree or 90 degree, because these three cases we have seen, this is theta which is different from 0, 180 and 90. Let any angle theta is not this. So if we resolve velocity vector in the direction of magnetic field, called parallel component v cos theta and the perpendicular component v sin theta. Now the angle between v cos theta and magnetic field is 0 degree. So this is the first case. Velocity v cos theta and b parallel है, theta 0 है, there is no force on it, so it is moving with the same velocity v cos theta. No force, no acceleration, constant velocity in the direction of magnetic field. Horizontal component कह सकते हैं. Now perpendicular component, because of 90 degree, it is moving in the circular path we have seen in the case 2. So if we combine both the motion, because of v cos theta component moving in a straight line, and because of this perpendicular component v sin theta, it is in circular motion. We combine these two motions, we find here this is the helical motion or helix, in the form of helix. This shape helix or helical motion will be there. We can find out the radius and we can find out the pitch of this helical path. Here radius will be, again by equating the two forces, magnetic force and the centrifugal force, we are getting the same result, but the perpendicular component is there, that is v sin theta actually. So here radius of helix will be r equal to mv perpendicular component upon qb, and time period 2 pi m upon qb, and frequency both are independent of speed as we have discussed earlier also. Now come to pitch. What is pitch? This is the linear distance covered in one circular path. So it is the speed or velocity horizontal v cos theta multiplied by the time period. Distance is equal to speed multiplied by the time. Speed is v cos theta, time is this one given by equation 2, 2 pi m upon qb. So this way the formula of pitch here is v cos theta into pi m upon b given by equation 4. Now very important discussion here. This is a repeated question in board also, NEET also, JEE also. Many times question comes here from this topic. Let us say one proton, neutron and alpha particle, helium nucleus. They are entering the magnetic field perpendicularly. We have to find out the ratio of proton, neutron and alpha particle. Now case 1, when the linear momentum P is equal to mv, that is constant, and all the three particles, proton, neutron, alpha particle entering perpendicularly in the uniform magnetic field, then we have to find the ratio of the radius. The formula of radius here is r equal to mv upon qb. mv nothing but p, linear momentum, and if linear momentum p is constant, then p also constant. Radius is directly proportional to 1 by q or inversely proportional to q. Then radius proton, neutron and alpha particle is 1 by q, means 1 for proton, and this is also neutron 1 and alpha particle 2. 1:1:2 का रेशियो है या चार्ज का, and इनका मास रेशियो है प्रोटॉन, न्यूट्रॉन, अल्फा पार्टिकल का 1:2:4. is the ratio of mass ratio 1:4 and charge ratio 1:2. So if multiplied with 2, this is the ratio of the radius when the linear momentum is constant. Now case 2 or question 2, you can say a proton, neutron and alpha particle, they are entering the magnetic field perpendicularly with the same kinetic energy. Here kinetic energy is constant for all these particles, proton, neutron and alpha particle. Then finding the ratio of proton, neutron and alpha particle of radius. We know the again mv is equal to p equal to what? 2me is the kinetic energy here. We know this relation. So putting the value of mv is equal to p is equal to what? Under root 2me here, and E kinetic energy 2 and B constant. So radius is directly proportional to under root m by here cube. So for proton mass is m, charge is q. For neutron mass is double 2m, charge is same q. For alpha particle charge is double and mass is 4 times. M by q, m by q, m by q cancel out. Then we are getting the ratio 1 root 2 and this is 1. 4 का root हो जाएगा तो 2 cancel होगा 1. So this is the ratio of radius of proton, neutron and alpha particle. 1 is to ratio root 2 is ratio 1. Now case 3, the proton, neutron and alpha particle are excited with the same potential difference and they enter perpendicularly in magnetic field. Then radius का formula है mb upon qb. mb is equal to p, को हमने लिखा root 2me is E kinetic energy is equal to work done qb. तो q कैंसिल करके ये रूट में आ जाएगा अंदर. यहाँ पे 2v and b कांस्टेंट है, तो रेडियस विल बी अंडर रूट m by q पूरे पे है बिकॉज वेलोसिटी पोटेंशियल डिफरेंस एंड magnetic field, potential difference and magnetic field constant. So this is the ratio. Rp, proton, neutron and alpha particle. M by Q, 2m by Q, 4m by Q. तो m by Q cancel कर देंगे यहाँ पे. 1 root 2 and इसका 2 cancel होकर root 2. So this is the ratio. बहुत common question है, अक्सर आते हैं तभी देखते. Now come to Biot-Savart Law. As per the Biot-Savart Law, suppose this is the wire here, current I is flowing here, and this is the current element. Current element means the small part of this conductor where current is flowing, small length dl. So IDL is called current element. Elemental portion of this wire, current is flowing. IDL is current element. From this current element, we are interested to find out the magnetic field at point P, which is at a r distance from this current element, point P, and at an angle of theta here. So the magnetic field depends on the current element, depends on the sin theta, inversely proportional to square of the distance. Combine them and take the proportionality constant mu naught upon 4 pi. This equation 1 is the Biot-Savart Law. If we write the same equation in the vector form, this is also called Biot-Savart Law, but in vector form, and equation 1 is the magnitude. So we have to learn it. Very important formula for Biot-Savart Law. dB is small, magnetic field is given by mu naught upon 4 pi ideal sin theta upon r square, where mu naught is called permeability of the vacuum, mu naught upon 4 pi. The numerical value here is, this is the constant, numerical value is 10 to the minus 7. Now, direction of magnetic field can be found out by, say, Fleming's right hand thumb rule. Actually, this is not called thumb rule, it is a Fleming's right hand curling finger rule. Curl finger rule. The right hand curl finger rule, not thumb rule exactly. But here, thumb in the direction of the current and curl finger will be in the direction of magnetic field. So here you can find out the thumb in the direction of current and curl finger will tell you the direction of magnetic field. The thumb is here, this is the opposite direction of magnetic field here. So we can apply easily. It's better to say it is curl finger rule. By using the right hand curl finger rule, we can find out the direction of magnetic field, and by using the right hand thumb rule, we can find out the direction of induced current. Here we are not using this right hand thumb rule, we are using right hand curl finger rule. Now clock rule. Suppose here this is the coil and current is flowing here clockwise. In the second case it is flowing in the anti-clockwise direction. Then it is making at the center south pole, north pole, like in the direction of current here like this. If you join coming the south, and suppose in the direction of current you join like this, it will be the north pole. So it is called the clock rule. We will use this clock rule here. The application of Biot-Savart law is first application to find the magnetic field at the center of the current carrying loop at the center here. Suppose this clockwise is the south pole, and by using the right hand curve finger rule, we are getting the direction of magnetic field at the center is inward by cross. Say if we are taking say small elemental portion ideal and this is the radius, the angle between current element ideal and R is 90 degree. We are using the Biot-Savart law, mu naught I dl sin 90 upon 4 pi R square. Sin 90 is 1. To find out the total magnetic field, we are integrating from 0 to 2 pi R. This way we are getting the whole figure. Small element will make a one parameter. So integration limit will be 0 to pi r. If we are integrating it, say dl will be 2 pi r. So it is 2 pi r, cancel out 2 pi and 1 r is cancelled. We are getting this magnetic field at the center is given by mu naught I upon 2 r. If there are n number of turns in the coil, it will be multiplied by n. So this is the formula of magnetic field at the center at O mu naught I upon 2 r into n. Second application here, to find out the magnetic field due to the straight long current carrying wire. Say this is the xy is the wire, here current is I like this, and here we imagine current element ideal from point P at a distance of r, and this is the distance L. From wire to point P, the distance is say A. At P point, we are interested to find the magnetic field. Using the Biot-Savart law, Db is equal to mu naught upon 4 pi I dl sin theta upon r square. But here dl is variable. कितना dl है छोटा सा बड़ा सा, like इस position में theta is also variable, this distance r is also variable. So dl, theta and r all three are variable. The question है आप किसके रेस्पेक्ट में इंटीग्रेट करेंगे. So we have to replace dl, sin theta and r in one variable. तभी possible है कि हम इंटीग्रेट करें with respect to one variable. So we are converting dl and theta and r in one variable. Suppose in this triangle OCP, this theta angle and this phi angle and 90. So theta plus 90 plus phi 180. So theta plus phi is what? 90. So theta will be 90 minus phi, and sin theta will be sin 90 minus phi means cos phi. So only sin theta को हमने cos phi से replace किया. Again this triangle OCP, cos pi is equal to a upon r base upon hypotenuse. So a upon r will be cos phi, so r will be a upon cos phi. R को replace कर दिया. Now in this triangle again OCP, tan phi is equal to L upon A. That will be L equal to A tan phi. It will be dl equal to A tan का हो जाएगा sec square phi d phi. So can replace sin theta with cos phi. R is equal to A upon cos phi. dl is equal to A sec square d phi. All the three values putting in equation 1. So dv is equal to mu naught upon 4 pi I. dl की जगह A sec square phi d phi. sin theta की जगह cos phi. R की जगह A upon cos phi. स्क्वायर है तो A square upon cos square phi. ना एक A कैंसिल हो गया. 1 upon cos square phi sec square phi ये भी कैंसिल हो गया. बच गया dv equal to mu naught upon 4 pi I upon A cos phi d phi. Now we are integrating both sides, and here limit should be, and here this is a angle is phi 1, this angle is phi 2. This clockwise angle is negative and anti-clockwise angle is say positive in maths. So limit should be in angle minus phi 1 to plus phi 2. We are putting the limit here minus phi 1 to plus phi 2. Cos phi का integration होगा sin phi. Limit is phi 1 to phi 2, but this is minus, this is plus. So it will be first upper limit minus lower limit. Sin phi 2 minus sin of minus phi 1, that is plus sin phi 1. So this way formula here of magnetic field net will be mu naught I upon 4 pi A and sin phi 1 plus sin phi 2 given by equation 2. There are special cases when wire is very long, infinitely long wire, for infinitely long wire, these angles phi 1, phi 2 will become, नीचे होगा तो बड़ा होता जाएगा, तो हो जाएगा तो phi 2 बड़ा हो जाएगा. So for infinitely long, phi 1 and phi 2 will be approaching to 90. So here for infinitely long wire, phi 1, phi 2 will be 90 degree. In the formula here, sin 90 1, sin 90 also 1, 1 plus 1 will be 2. कैंसिल करके ये आ जाएगा फॉर्मूला 2 से 4 कैंसिल होके क्वेश्चन 1. तो फॉर्मूला फॉर मैग्नेटिक फील्ड फॉर इनफाइनाइटली लॉन्ग वायर गिवन बाय म्यू नॉट I upon 2 pi a. Question 1. If the wire is semi infinitely long, एक साइड से 0 है, एक साइड से 90 है, phi 1 0 है तो phi 2 90, phi 1 90 तो phi 2 0 हो जाएगा. So this way B naught will be mu naught I upon 4 pi a, 1 plus 0 और 0 plus 1. ये मिल गया फॉर्म गिवन बाय इक्वेशन 2. If suppose P point on the wire itself or in the line of sight of the wire, then phi 1 phi 2 will be 0 or 180. sin 0 और sin 180 दोनों 0 है तो मैग्नेटिक फील्ड भी 0 हो गया. पर फाइनाइट वायर, और पहले जो फॉर्मूला था फाइनाइट का वही लिख देंगे गिवन बाय से इक्वेशन दिस 2 सेम फॉर्मूला फॉर फाइनाइटली लॉन्ग वायर. नाउ वेरी इंपॉर्टेंट केस से to find the magnetic field at a point on the axial position of a circular current carrying wire or coil. This is the circular coil, current carrying coil at point P, which is the axis of this coil. So at this axial position point P, we have to find out the magnetic field due to this current carrying coil. Using the Biot-Savart law, here dB dash or dB, here this is the portion at point C, ideal, and here at D, ideal. Because of ideal, this is the magnetic field dB. Because of this lower ideal, this is the magnetic field dB dash. ना कोई change angle में है, ना distance में, ना कुछ. तो dB and dB dash numerically they are same, but in different directions. So numerical value magnitude is same given by Biot-Savart law mu naught upon 4 pi ideal sin 90 upon इस डिस्टेंस का स्क्वायर करेंगे तो अंडर हट जाएगा यहाँ से. The theta angle between this current element and the R is 90. फिगर में नहीं दिख रहा because figure is 2 dimensional. This actual situation here is 3 dimensional. So this angle is 90, sin 91. Now if this angle is phi, this must be phi. This angle is phi, this must be phi. If we resolve dB in horizontal and vertical, horizontal will be dB sin phi and vertical will be dB cos phi. Similarly, this is dB dash cos phi and here dB dash sin phi. This will be cancel out in pair. So vertical component dB cos phi and dB dash cos phi cancel out in pair and sin component will be added up. This and this both are equal here, but it is not 2, not twice नहीं होगा. There are many elemental portions. So all the components of cos component will be cancel out and all the components sin component will be added up. ये बहुत सारे हैं तो हमको इंटीग्रेशन करना पड़ेगा ना कि डबल. Find it. So horizontal component dB sin phi all added up by integration dB sin phi. Sin phi की वैल्यू हो जाएगी a upon under root x plus a square. That can be written mu naught upon 4 pi I a upon x square plus a square power 1 and half, so 3 by 2 and dl. टोटल निकालने के लिए हम लिमिट की इंटीग्रेट करेंगे 0 to 2 pi a the perimeter. So here we are integrating the limit here 0 to 2 pi a. इसका इंटीग्रेशन हो जाएगा L 0 to 2 pi a, so 2 pi a minus 0 pi only. We can write like this. If n number of turns are there in the coil, we have taken only single turn. If there are n number of turns, the magnetic field will be n times multiplied. Like so, this is the final equation of magnetic field at the axial position given by equation 2. Here case 1, when at the center, if we are interested to find out the magnetic field at the center, it means at O. So for O, x will become 0. So at the center, put x equal to 0 here, will be 0. So a square upon power 3 by 2 cancel out, so a cube बचेगा. a square से cancel होके a बच गया. Here 4 pi and 2 pi, so नीचे 2 आ जाएगा. So it will be the formula mu naught I upon 2a into n we have seen earlier also. The same case be at the center. Now if x is very large than a square can be neglected in equation 2. a को neglect कर देंगे हम लोग x के रेस्पेक्ट में, तो ये फॉर्मूला मिल जाएगा इक्वेशन 4. It is at a far off distance than a radius of the coil. Now we know what is capital M. Capital M is the dipole moment given by NIA. pi a square is the area, जगह a भी लिख सकते हैं आई आर स्क्वायर, तो एन आई पाई ए स्क्वायर की जगह हम लिखेंगे एम डाइपोल मोमेंट का यूनिट होता है एम्पियर स्क्वायर, इसकी जगह लिख दिया हमने एन आई पाई ए स्क्वायर, एन आई पाई स्क्वायर, इस पूरे की जगह लिख दिया हमने एम की फॉर्म में आ जाएगा. तो हमने क्वेश्चन 4 को इस तरह से भी लिख सकते हैं, इसकी जगह हम लिख दिया डिस्टेंस एक्स बहुत ज्यादा है AC, तो ऐसे भी लिख सकते हो. इक्वेशन 3 कैन बी रिटर्न, इक्वेशन 2 कैन बी रिटर्न एंड लाइक इक्वेशन 5, and equation 4 can be written like equation at the center is maximum while x is more and more be decreasing, as we can see by the this is the graph roughly. Now come to Ampere Circuital Law. Sometimes it is called say Gauss law comparable in the electrostatics. As per the Ampere's law, the line integral of magnetic field B around the closed path is given by 1 by mu naught time the total current threading, total current passing through the loop. So mathematically integration for the closed path lengthwise P dot dl equal to mu naught I is the total current threading. Proof of this, taking the LHS B dot dl, P and dl both are in same direction, so cos 0 1, P की वैल्यू मालूम हमको यहाँ से इनफाइनाइट लॉन्ग वायर के लिए म्यू नॉट आई अपॉन 2 पाई आर, एंड डीएल का इंटीग्रेशन हो जाएगा टू लिमिट है 2 पाई आर इक्वल 2 पाई आर, 2 पाई आर 2 पाई कैंसिल, म्यू नॉट आई इट इज द आरएचएस. So this proof of Ampere Circuital Law is very simple. LHS to RHS, nothing is there. Applications of Ampere Circuital Law. First, to find out the magnetic field due to infinite long wire, very long wire, straight wire. This is the straight wire carrying current I here. At a distance of R, we are interested to find out the magnetic field at point P. P and dl both are in the same direction, so angle between them is 0 degree. Using the Ampere Circuital Law, integration for the closed path equal to mu naught I is the effective current here, total current I रहेगा. So B dl cos 0, P निकालना है, कोई वैल्यू पुट नहीं करेंगे. इंटीग्रेशन फॉर दिस dl इट विल बी 2 पाई आर, 2 पाई आर को नीचे ले गए. सो दिस इज द फॉर्मूला ऑफ मैग्नेटिक फील्ड ड्यू टू लॉन्ग वायर, और इनफाइनाइट लॉन्ग वायर का यही फॉर्मूला होता है. बट डेरिवेशन हियर इज वेरी सिंपल. यूजिंग द एम्पियर सर्किटल लॉ, तो 3-4 लाइन में डिराइव हो गया. पहले जो किया था बहुत ही लेंथी था. तो दिस इज द वेरी गुड यूज ऑफ एम्पियर सर्किटल लॉ. इनफाइनाइट लॉन्ग वायर की वजह से हमें निकालना मैग्नेटिक फील्ड, वेरी सिंपल. नाउ नेक्स्ट केस इज वेरी इंपॉर्टेंट. टू फाइंड आउट द magnetic field due to the current carrying cylindrical wire, we are using the Ampere Circuital Law. Here this is the radius R of the cylindrical wire, suppose length is L, the total current is I. We are taking the point P1 which is very well inside this cylindrical wire or cylinder. P2 point on the surface of the cylinder, the radius R, variable radius is equal to R, radius of the cylinder, and P3 point is outside, so variable radius is more than this radius of cylinder. So we have to find out the magnetic field inside, on the surface and outside using Ampere Circuital Law. But inside there are two cases, if the cylinder is hollow or cylinder is solid. First we are taking the hollow cylinder. Ampere Circuital Law, integration for the closed path, P dot dl is equal to mu naught I effective. So ये hollow है, तो all the current is passing through the surface, there is no current inside. So effective current inside is 0 because all the current is passing through the surface only for hollow cylinder. Hollow तो current कहाँ से होगी? So this way magnetic field inside is 0 for hollow. Now taking the solid cylinder, here current is uniformly distributed to the all cross sectional area. It's called uniform distribution of current. Now using the Ampere Circuital Law, integration for the closed path B dot dl equal to mu, and mu naught नहीं ले रहे हैं because मीडियम है, सॉलिड है. mu naught होता है वैक्यूम के लिए. It is mu and I effective. I effective is not I. अगर पूरे में अगर क्रॉस सेक्शन एरिया कैपिटल आर में करंट आई है तो स्मॉलर पोर्शन में करंट आई नहीं होगा, कुछ कम होगा. तो दिस इज द इफेक्टिव करंट इन द स्मॉलर पोर्शन एरिया एंड दिस इज द परमेबिलिटी ऑफ द medium solid. Whatever is the medium material of the cylinder, we are taking the permeability of the medium. And permeability of the medium, relative permeability is defined as permeability of the medium upon permeability of the vacuum after cross multiplication. We can write like this: mu equal to mu r into mu naught. And what is the effective current? We have to find out the effective current by unitary method. The current is uniformly distributed here, whole area pi r square, the total current I, and we have to find out the current effectively in this portion small cross section where radius small r, variable radius is less than r. See here. Now, by unitary method, if the total area pi r square, the total current here is for whole current threading per unit area के नीचे चला जाएगा I upon pi r square, और smaller area से multiply कर देंगे तो pi will be cancel out. I effective will be I r square, small r square upon capital R square. We are using this equation 3 here for effective current. Now put it, the value of effective current from equation 3 in equation 2, we are getting, यहाँ इसकी जगह इफेक्टिव हमने ये ले लिया like this. So B dl cos 0 equal to mu naught r, mu naught I स्मॉल आर स्क्वायर अपॉन कैपिटल आर स्क्वायर का इंटीग्रेशन होगा 2 पाई आर, एक आर से एक आर कैंसिल कर दिया हमने. बी इनसाइड विल बी म्यू आर म्यू नॉट आई अपॉन आर स्क्वायर एंड आर. इफ हियर इनसाइड द ब्रैकेट कांस्टेंट, सो बी इनसाइड इज डायरेक्टली प्रोपोर्शनल टू स्मॉल आर इनसाइड द magnetic field inside this cylinder. The inside magnetic field is directly proportional to R. Now at position point P3 outside point, here this is the point P3 outside point, के अंदर क्या कितना होगा, टोटल करंट आ गई आई. So here at point P3 R is more than R. At point outside point, Ampere Circuital Law, integration for the closed path B dot dl equal to mu naught I. यहाँ पे mu naught क्यों है, वैक्यूम है, I टोटल करंट. तो B dl cos 0 mu naught I का इंटीग्रेशन हो जाएगा dl का 2 pi r, ये नीचे ले गए. So B outside point के लिए mu naught I upon 2 pi r. It is very similar to infinite long wire at a distance of r. Means सिलेंडर के बाहर जितने पॉइंट्स हैं सबके लिए इनफाइनेटली लॉन्ग वायर जैसा फॉर्मूला मिल रहा है. इट इज बिहेविंग लाइक दैट. आउटसाइड के लिए पूरा ऐसा लगेगा जैसे कि करंट एकदम वायर पर ही, सेंटर पर ही है, एक्सिस पर है. तो आउटसाइड पॉइंट के लिए इट इज डायरेक्टली प्रोपोर्शनल टू 1 by r. On the surface, we simply replace small r with capital R. This is the maximum value. So we are plotting the graph between say magnetic field B and distance r from the center. Inside hollow cylinder, magnetic field is 0 here, and on the surface is maximum, and outside it is decreasing reciprocal to the distance. B outside is inversely proportional to 1 by r. That is 0. It is solid, it is not low, but is increasing. At center it is 0, up to the surface it is increasing directly proportional to r, and at the surface it is maximum value, and after that it is decreasing reciprocally to the r, and maximum going up. Now again very important, to find out the magnetic field inside the current carrying state solenoid. Say the state solenoid very long, length of this solenoid is very large in comparison to the radius. So इससे लाइन्स ऑफ फोर्स बाहर आ रही हैं. अगर बहुत ही ज़्यादा लेंथी है ये, तो यहाँ पर ये CD पोर्शन में मैग्नेटिक फील्ड कितना होगा, फॉर द CD पोर्शन इट इज अप्रोक्सीमेटली 0. लाइन्स ऑफ फोर्स यहाँ आ ही नहीं है. लाइन्स ऑफ फोर्स इन तो मैग्नेटिक फील्ड किस बात, तो मैग्नेटिक फील्ड इज वेरी स्मॉल, नेग्लिजिबल here for CD portion. Now we are using the Ampere Circuital Law for the closed path A, B, C, D. Lines of force are entering, so this is the south pole. Exiting out, it is the north pole. So south to north inside direction होगा, and AB wire के लिए south to north angle between the this wire AB and the magnetic field is 0 degree. For this BC wire and AD wire, this angle is 90 degree. ये वायर ऐसे है, magnetic field इसको perpendicular इस तरह है. South to north magnetic field and this wire both are perpendicular. इसलिए direction A to B है magnetic field and CD के लिए opposite है, so theta will be 180. इन्हें हमने closed path को break किया दो पार्ट में, A to B, B to C and C to D and D to A. 4 part. Mu naught I effective कैसे लेंगे? Suppose here in this wire total number of turns will be small n, this is the number of turns per unit length multiplied by length of AB wire, n into L हो गया total number of turns, effective current हो जाएगी I से multiply कर दिया, इसकी जगह हमने लिख दिया NLI. Now A to B 0 degree angle, B to C and D to A angle 90 degree, and here angle 180 degree, but magnetic field is negligible, so it is approximately 0. Now first part angle 0 degree, cos 90 की वजह से 0, magnetic field negligible इसलिए 0, cos 90 0. Only first part is there, second third fourth part 0 हो गया. इसको हम लिखेंगे L, B into L 1 इक्वल टू, ये सब 0 है, म्यू नॉट NLI, L कैंसिल हो गया यहाँ पे, इट विल बी B इनसाइड म्यू नॉट NI. एक एंड पे लेंगे तो वन पोल इज इफेक्टिव ओनली, इसका हाफ हो जाएगा. तो एंड पे आइदर नॉर्थ पोल और साउथ पोल, इट विल बी हाफ ऑफ दिस मैग्नेटिक फील्ड इनसाइड. केस 1 इनसाइड के लिए, केस 2 जस्ट किसी एक एंड पर, हाफ ऑफ म्यू नॉट NI. नाउ वी आर टेकिंग द मैग्नेटिक फील्ड इनसाइड द करंट कैरिंग toroidal solenoid. This is the shape here of solenoid, it is called toroidal shape, toroidal solenoid, or sometimes it is called only toroid. The current is entering here and like this it is coming out at point P, at point Q there is no lines of force coming out. ये अंदर ही अंदर घूमेगा, बाहर नहीं निकलेगा. So at point P, at point Q there is no lines of force, so magnetic field must be 0 at point P and point Q also. Magnetic field is only limited to this part, internal part here. At point S, magnetic field is not 0 and DL is parallel to this, so angle between B and DL is 0 degree. जहाँ जहाँ lines of force नहीं है वहाँ magnetic field पक्का 0, so P and Q. Now we are considering 3 radius. At point P के लिए radius R1 हो गया, ये radius R2 हो जाएगा, radius R3 S के लिए. यहाँ पर हम लेंगे इफेक्टिव करंट ही 0 है P के लिए और Q के लिए, तो मैग्नेटिक फील्ड अपने आप 0 हो जाएगा, कोई लाइन्स ऑफ फोर्स ही नहीं है. P पॉइंट P और B1 is 0, P at point Q also 0. Now we are considering this point S is radius R2 point. R2 is the radius, S is the point. यहाँ क्या मैग्नेटिक फील्ड 0 नहीं होगा, इस पोर्शन में बात कर रहे हैं हम पोर्शन. So here for loop 2 point S R2 radius, we are applying the Ampere Circuital Law. For loop 2 B2 बोल दिया इसको, तो DL equal to mu naught I effective. I effective will be number of turns per unit length multiplied by the length means perimeter into I. So this is the effective current. Put the value here. I effective B DL and cos 0 1, DL की जगह 2 pi r हो जाएगा. So this 2 pi r cancel out. It will become B2 will be mu naught NI inside portion of radius R2 at point S. तो इस पोर्शन में केवल मैग्नेटिक फील्ड होगा, बाकी पीयर क्यू नहीं होगा या कहीं भी नहीं होगा, केवल इस solenoid के अंदर होगा. तो दिस वे वी आर गेटिंग द मैग्नेटिक फील्ड इनसाइड म्यू नॉट NI. किसी एंड की बात नहीं है क्योंकि यहाँ पे सर्कुलर में एंड होता ही नहीं, तो एंड वाला इनवैलिड पॉइंट हो गया. नाउ फोर्स ऑन करंट कैरिंग कंडक्टर प्लेस्ड इन मैग्नेटिक फील्ड एक्सटर्नल यूनिफॉर्म. सपोज हियर इन द कंडक्टर electron is moving in the magnetic field, conductor length is L, so force on electron, also magnetic Lorentz force on electron given by Q V क्रॉस B. ये फॉर्मूला पहले से आता है हमको. इलेक्ट्रॉन की बात कर रहे हैं तो माइनस ले लिया, मैग्नीट्यूड में माइनस नहीं लेंगे. V क्रॉस ड्रिफ्ट वेलोसिटी इनटू मैग्नेटिक फील्ड, तो V D इज द ड्रिफ्ट वेलोसिटी. टोटल फोर्स विल बी, ये तो एक इलेक्ट्रॉन की बात हो गई, तो बट देयर n नंबर ऑफ इलेक्ट्रॉन्स n से मल्टीप्लाई कर देंगे. व्हाट इज n? कैपिटल N टोटल नंबर ऑफ इलेक्ट्रॉन, स्मॉल n मींस नंबर डेंसिटी नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम मल्टीप्लाइड बाय द वॉल्यूम. n इनटू वॉल्यूम कितना हो जाएगा? एरिया इनटू लेंथ. तो कैपिटल N विल बी स्मॉल n इनटू वॉल्यूम AL. मल्टीप्लाई कर दिया जाए, टोटल हमको मिल जाएगा फोर्स NAL मल्टीप्लाइड बाय फोर्स ऑन वन इलेक्ट्रॉन गिवन बाय इक्वेशन 1. तो मल्टीप्लाई करके ऐसे लिख सकते हैं, I इक्वल टू व्हाट? NEAVD. करंट में पढ़ा था हमने, NAEAVD. N नंबर डेंसिटी, इलेक्ट्रॉनिक चार्ज, एरिया एंड वी डी इज द ड्रिफ्ट वेलोसिटी, इस जगह हमने आई लिख सकते, आई एल क्रॉस बी, ये हो जाएगा टोटल फोर्स, माइनस साइन को हमने इग्नोर मार दिया। फोर्स की डायरेक्शन निकाल सकते हैं तो माइनस का कोई सेंस नहीं रहेगा। तो फोर्स फॉर्मूला विल बी आई एल बी साइन थीटा, इसका मैग्नीट्यूड लिखते हैं तो हो जाएगा आई एल बी साइन थीटा or BIL. Now, force between two parallel current carrying conductor. Parallel means say there are two parallel wires, current here in the same direction, different current I1, I2 at a separation distance R. We have to find out the force on these two wires. If they are parallel, current in I1, I2 in both the wires is in same direction, then there is attraction force between the two wires. Suppose here, how to find out this? Due to current in number one wire I1, a magnetic field here is given by mu naught I upon 2 pi. ये फॉर्मूला पढ़ा था हमने इनफाइनाइटली लॉन्ग वायर के लिए, वो यूज कर लिया। So B1 is the magnetic field to I1 at a distance of R is given by mu naught I upon 2 pi R. ये डायरेक्शन कैसे लेंगे? राइट हैंड कर्ल फिंगर रूल। तो यहाँ पे हमने रखा I1 पे और इनवर्ड मैग्नेटिक फील्ड मिल जाएगा। सिमिलरली I2 की वजह में आउटवर्ड मैग्नेटिक फील्ड मिलेगा B2। B1 का फॉर्मूला होगा म्यू नॉट I1 अपॉन 2 पाई R, B2 का म्यू नॉट I2 अपॉन 2 पाई R। इट इज इनवर्ड, तो इज आउटवर्ड यूजिंग द फ्लेमिंग्स राइट हैंड कर्ल फिंगर रूल। नाउ फोर्स ऑन wire 2 is the magnetic field B1 and current is I2. We are applying now Fleming's left hand rule, father mother child. So forefinger magnetic field inward, current is upward, so force will be F21 is towards left hand. Force का formula BIL sin 90. F21 means force on 2 due to 1. It will be B1 I2 current, L is the length of the conductor. So B1 की value mu naught I1 I2 upon 2 pi R into L. Similarly on wire 1 due to 2 B2 I1 L, same formula है हमको। ये towards left होगा, towards right होगा, that's why attraction force is there between the two wires. Now अगर हम लिखते हैं force per unit length, इसे L से डिवाइड कर देंगे यहाँ पे, F121 upon L, mu naught I1 I2 upon 2 pi R. Similarly F12 upon L, अगेन द सेम म्यू नॉट I1 I2 अपॉन 2 पाई R। तो फोर्स पर यूनिट लेंथ का फॉर्मूला सेम होगा और बोथ द वायर्स। फोर्स का फॉर्मूला डिफरेंट हो सकता है क्योंकि वायर नंबर 1 वायर नंबर 2 की लेंथ डिफरेंट होगी, माइंड इट, बट फोर्स पर यूनिट लेंथ सेम फॉर्मूला आएगा। फोर्स का फॉर्मूला डिफरेंट होगा, डिपेंड्स ऑन L। अगर L से डिवाइड कर देंगे, फोर्स पर यूनिट लेंथ में L नहीं आ रहा है, इसलिए फॉर्मूला सेम होगा गिवन बाय इक्वेशन 5। लर्न इट, वी हैव टू लर्न इट। फोर्स पर यूनिट लेंथ ऑलवेज म्यू नॉट I1 I2 अपॉन 2 पाई R सेम होगा। लेंथ नहीं है, लेंथ डिफरेंट हो सकती है, फोर्स पर यूनिट लेंथ डिफरेंट नहीं होगा, सेम होगा, फोर्स डिफरेंट हो जाएगा ऑफ लेंथ। नाउ इफ द करंट आर इन एंटी पैरेलल डायरेक्शन, मींस करंट इन वन इज I1 ऊपर है, I2 नीचे है, तो बिकॉज ऑफ दिस I1 मैग्नेटिक फील्ड म्यू नॉट I1 अपॉन 2 पाई R, बिकॉज दिस B2 म्यू नॉट I2 अपॉन 2 पाई R, और यहाँ पर मैग्नेटिक फील्ड इनवर्ड हो गया दोनों, यूजिंग द राइट हैंड कर्ल फिंगर रूल। B1 B2 दोनों ही इनवर्ड है। नाउ यूजिंग द Fleming's left hand rule, inward magnetic field downward, this is the force on 2 due to 1 is away. Similarly F1 2 is also away. That is why if the current in the two wire in opposite direction, repulsive force will be acting on it. If the current in the two wires in the same direction, then attraction force will be there. एंड फोर्स पर यूनिट लेंथ का फॉर्मूला सेम होगा, चाहे वायर 1 हो, चाहे 2 हो, चाहे दोनों पैरेलल हो, चाहे एंटी पैरेलल हो, इट विल बी द सेम। अट्रैक्शन एंड रिपल्सन किस पर डिपेंड करेगा? सेम डायरेक्शन करंट, अट्रैक्शन, अपोजिट डायरेक्शन करंट, रिपल्सन। नाउ वेलोसिटी सेलेक्टर, हियर वी आर कंसीडरिंग इलेक्ट्रिकल फील्ड as well as magnetic field, both are present perpendicular to each other and the charge particle entering perpendicular to both electrical and magnetic field. Using the left hand rule, magnetic force here is this side upward, because of this it is moving and like this। इसका इलेक्ट्रिकल फील्ड पॉजिटिव चार्ज में इलेक्ट्रिकल फील्ड की डायरेक्शन में आएगा फोर्स, तो F मैग्नेटिक फोर्स एंड F इलेक्ट्रिकल फोर्स दोनों अपोजिट है। बाय द वे दिस हियर फर्स्ट ऑफ ऑल वेलोसिटी वेक्टर इज परपेंडिकुलर टू इलेक्ट्रिकल फील्ड एंड परपेंडिकुलर टू मैग्नेटिक फील्ड, तीनों एक दूसरे के परपेंडिकुलर। लॉरेंज इलेक्ट्रिकल फोर्स ऑन चार्ज QE एंड लॉरेंज मैग्नेटिक फोर्स इज इक्वल टू QVB sin 90। If both are equal and opposite, then FE will be QE and this will be Q. V be sin theta, Q cancel होके V मिल गया हमको. So this is the condition. If this condition is applied, if velocity is E upon B ratio, then this charged particle will be going without any deflection because electrical force and the magnetic force, they are equal and opposite. In this case, velocity is given by E upon B. Now consider here, this is also very important topic से का बोर्ड में डेरिवेशन आ चुका है कई बार. Here torque acting on a current carrying coil in uniform magnetic field. Let us consider here this rectangular coil P2RS of length L and breadth B. It is kept in such a way that with the uniform magnetic field, the plane of the coil is making an angle theta and the normal to the magnetic field, normal to the plane of the coil with magnetic field making an angle alpha. So theta plus alpha is 90 degree. ये magnetic field है, plane से theta angle मारा normal से alpha. So theta plus alpha should be 90. So theta will be 90 minus alpha. Cos theta will be cos 90 minus alpha means sin alpha. This way the relation between theta and alpha is given by cos theta is equal to sin alpha. Now here in this triangle PQZ, cos theta will be PZ upon hypotenuse PQ, which is small b, breadth of this coil. So PZ will be B cos theta. Now force on PQ wire force. So use करेंगे Fleming left hand rule, and here angle is not 90 degree, angle is theta. So B2 will be BIB sin theta. Similarly on F2 force on RS wire, which is making angle between the magnetic field and the current, is 180 minus theta. So this is the force in upward direction using the Fleming left hand rule. BIB sin 180 minus theta. Sin 180 minus is sin theta. So F4 and F2 will be cancel out. Now here force F2 will be BIB sin theta and F4 will be BIB sin 180 minus theta is equal to what? Sin theta. So equation 2 and equation 3, F2 and F4, they are equal and opposite also. They are cancelling out in pair, equal and opposite. So net force is 0, net torque is also 0. F2 F4 क्या है? तो उसी डायरेक्शन में लग रहा है वर्टिकल सस्पेंशन लाइन पे. तो परपेंडिकुलर डिस्टेंस 0 हो गया, मीन्स मोमेंट आर्म 0 है, तो टॉर्क भी नहीं लगेगा, फोर्स भी नहीं. तो नो लीनियर मोशन, नो रोटेटरी मोशन. Now considering force on SP arm, SP means here this SP magnetic field and current में एंगल हो जाएगा 90. Similarly QR and magnetic field में भी एंगल 90 है. Using the left hand rule, magnetic field and ये नीचे है तो ये ऊपर हो गया upward, F1 BIL sin 90, BIL upward and this BIL F3 downward. They are equal and opposite, so net force यहाँ भी 0 हो जाएगा. Considering here this F1 BIL sin 90 given by equation 5 outward out of the page, and force on QR it will be BIL inward going into the page. They are equal and opposite, so net force is 0. But net torque is not 0. Moment arm is not 0 here. So torque is given by the force multiplied by the perpendicular distance PZ in the figure. This is called moment arm. ये already found say by equation 4. PZ की जगह B cos theta लिखेंगे यहाँ. Now putting it here, say PZ will be B cos theta. Now L into B is the area, and suppose number of turns are N, then multiply कर देंगे N से. So torque will be NIA B cos theta. NIA की जगह हम M लिखेंगे. What is M? The dipole moment. NIA बहुत बार देख चुके हैं फॉर्मूले को. So NIA की जगह हमने M लिख दिया. Cos theta को पहले रिप्लेस कर चुके हैं ऑलरेडी बाई sin alpha. It can be written as MB sin alpha, M की वैल्यू NIA. Equation 8 या equation 9 एक ही बात है. In vector notation it can be written as M cross B. Cos theta नहीं लेंगे, यहाँ डॉट प्रोडक्ट आएगा. डॉट प्रोडक्ट बिल्कुल सही बात है. Right hand side, but left hand side में problem. The torque is not a scalar, it is a vector quantity. इसलिए cos theta को अल्फा में चेंज करना. अब यहाँ पे वेक्टर में भी कोई प्रॉब्लम नहीं है, स्केलर में तो वैसी प्रॉब्लम नहीं. Now we have to learn these two. This torque formula in scalar quantity magnitude and this in vector quantity M cross B. The value of M is NIA. Now moving coil galvanometer. This is the device, say instrument, very sensitive. It can measure up to very small current up to the order of say 2 microampere. Because of this there is deflection here. can detect deflection, it can detect very small, it can measure very small current. So very sensitive device. The principle is whenever current carrying conductor is placed in the magnetic field, there is a torque acting on it. इसका derivation ही कर रखा है. So here this is the suspension point through the wire is coil is hanged here between the north and south pole in magnetic field. This is the wire called phosphor bronze strip, and this is the spiral spring, and inside soft iron core is kept. Soft iron core. Soft iron से क्या होगा? परमेबिलिटी बहुत ज्यादा, लाइन्स ऑफ फोर्स कंसंट्रेट हो जाएंगी. And by the deflection of this torque, this pointer deflects here on the uniform scale here, and this phosphor bronze strip hanging from the suspension point, it means whole coil and shorten core is hanging on this wire. This wire should be very thin, rotate ho jaye easily, and very strong mechanically, so it should not be broken by the weight of this coil plus soft iron core. So here, as by the deflecting torque, coil rotates, so there is twist in the phosphor bronze also, and energy is stored in the spiral spring. Because of this, restraining torque develops in the phosphor bronze strip, and here as the coil rotates, there is phosphor bronze strip also rotates. Just twisted here, potential energy stored in the spiral spring. As a result, this is restraining torque develops. The restraining torque is given by K theta. This torque of R means restraining torque. K is called torsional constant. Theta is the angle of twist. Phosphor bronze strip is not a very simple wire, but is very special alloy here. There are some properties of this wire or strip. It should be very light and very thin also, and very strong also. It should be conducting. Microampere current pass through it, so it should be conductor. And there's no rust, rustless होना चाहिए. No initial twist. Initial twist होगा तो रीडिंग गलत हो जाएगी. And very important points here, this restraining torque is directly proportional to angle of the twist. In the equilibrium condition, when the restraining torque is just equal to the deflecting torque, this K theta is the NIAB sin alpha. So theta is given by NAB upon this K, नीचे चला गया I and sin alpha. This is the formula of deflection theta, where here is NAB upon K is called galvanometer constant. Actually, galvanometer constant is the reciprocal of this. Anyway, this is also a constant quantity. Sometimes it's called figure of merit. Current by the unit deflection is called figure of merit. Actually, it is 1 by G. 1 by G is a constant. So this is also a constant. Galvanometer constant from 1 by G बोल रहा. Now, this angle of twist or deflection depends on two factors rather than one. One is I, other is sin alpha. यहाँ पे एक पे डिपेंडेंसी नहीं है, एक से ज्यादा पर तो आपको यूनिफॉर्म स्केल नहीं मिलेगा. यूनिफॉर्म स्केल कब मिलेगा? When sin alpha is हटा दें. ऐसे तो नहीं हटेगा, because the coil rotates, plane of the coil also rotates, normal to the plane, and the magnetic field alpha is also changing. तो जब coil में rotation आएगा तो जब this torque, तो alpha भी change होगा. तो कैसे हटाएंगे? ये बड़ा मुश्किल सी बात. Not very easy. But one arrangement is done so that despite rotation, alpha is always a constant quantity. See how? To get the uniform scale, alpha should not vary. It is a constant quantity. Despite rotation, it can be achieved by the using. There are two things. One is horseshoe magnet. Magnet is of the shape of horseshoe, and the soft iron core is there. This arrangement to get rid of the factor sin alpha is called radial magnetic field. A board में question आता है, what is radial field? How can you achieve it? So नॉर्थ साउथ पोल को हमने किस तरह से लिया है? इन द फॉर्म ऑफ ए horseshoe magnet. We know lines of force are originating from the north pole terminating to the south pole like this. Here, if coil rotates, this magnetic field north to south also rotates here. ये डायरेक्शन हो जाएगा मैग्नेटिक फील्ड के, यहाँ पे ऐसे हो जाएगा. यहाँ पर ट्रेस है, फिर ये है, यानी मैग्नेटिक फील्ड भी रोटेट कर रहा है. कॉइल रोटेट्स, मैग्नेटिक फील्ड आल्सो रोटेट्स, सो अल्फा रिमेन्स द सेम थ्रूआउट डिस्पाइट एनी रोटेशन. पोजीशन में भी किस पॉइंट पर अल्फा इज 90 डिग्री. So this can be achieved, alpha is 90 always, sin 90 is always 1, can be achieved by using the horseshoe magnet. And why we are using this soft iron core? Because soft iron cores concentrate the lines of force. The permeability or the susceptibility, relative permeability or susceptibility of this soft iron is very very good, roughly 1000. इन दोनों के कॉम्बिनेशन से हमको always we get say alpha 90, sin 90, sin alpha 1. ये हमको sin alpha वाला कांस्टेंट जो फैक्टर था वो हट गया. तो नाउ थीटा इज गिवन बाय NAB अपॉन KI. NAB अपॉन K तो पहले से कांस्टेंट है. थीटा इज डायरेक्टली प्रोपोर्शनल टू करंट I. So this way we are getting the uniform scale and equal divisions on a scale. This is called uniform scale. So by using radial magnetic field, this is uniform scale can be. Now by this formula, theta upon I equal to what? NAB upon K. So current sensitivity is defined as the deflection by the unit current. Question definition में कोई problem नहीं. At 1 ampere is very very large. When we are talking about the galvanometer measuring the current of the order of microampere, then 1 ampere तो 10⁶ एक लाख गुना ज्यादा. So by definition it's okay. Deflection by 1 ampere current, 1 ampere तो हम दे ही नहीं रहे. So current sensitivity here means large deflection by the very very small current of the order of microampere current. Current sensitivity is can be increased by the numerator part NAB and by decreasing the denominator part K. So IS current sensitivity can be increased by increasing the NAB and by decreasing the K. And voltage sensitivity similarly theta upon V by 1 volt. अगेन कहाँ 0.02 वोल्ट हम मिली एम्पियर में ही दे रहा है. तो इसका मतलब क्या होगा कि ये 1 वोल्ट ठीक नहीं है, बहुत ज्यादा है. तो वोल्टेज सेंसिटिविटी मीन्स लार्ज रिफ्लेक्शन बाय वेरी वेरी स्मॉल voltage across the galvanometer coil. So here theta upon V NAB upon KR, V is equal to IR. यहाँ पर R क्या है? रेजिस्टेंस ऑफ द कॉइल. तो दिस द वोल्टेज सेंसिटिविटी फॉर्मूला मिल गया हमको. बट इम्पॉर्टेंट हियर इफ वी इंक्रीज द A, P and decreasing K, current sensitivity, voltage sensitivity both increases by the formula you can see. But here very confusing. But this question is repeating question. बहुत बार पूछ ले रहे हैं हम लोग से. If we increase N, then current sensitivity by the formula NAB, N ऊपर है न्यूमरेटर में. करंट सेंसिटिविटी तो इंक्रीज होगा, में इंक्रीज हो जाएगा. But voltage sensitivity is a constant. By increasing the number of turns, there is no change in the voltage sensitivity. Reason behind here is voltage sensitivity NAB upon KR. अगर N को इंक्रीज करते हैं तो नंबर ऑफ टर्न्स इंक्रीज होने से लेंथ इंक्रीज होगी, वायर की लेंथ इंक्रीज होने से रेजिस्टेंस इंक्रीज होगा. तो यहाँ पर N और R एक दूसरे के इफेक्ट को नलीफाई कर दे. दैट्स व्हाई देयर इज नो चेंज इन द वोल्टेज सेंसिटिविटी. इवन इफ करंट सेंसिटिविटी इंक्रीज, देयर इज नो चेंज इन द वोल्टेज सेंसिटिविटी. ये N के केस में होगा. नंबर ऑफ टर्न्स इंक्रीज कर आपकी बात, बाकी के लिए तो दोनों इंक्रीज हो. तो दिस इज द रीजन वी कैन जस्टिफाई इट, वी कैन एक्सप्लेन दैट बाय इंक्रीजिंग N current sensitivity increases but voltage sensitivity there is no. Now we can convert galvanometer into ammeter. We know galvanometer is very sensitive device. It is measuring the millimicroampere current. Typically we are taking by an example. If say suppose galvanometer resistance of the coil is 10 volt let and milliampere current passing here, 1 milliampere current is sufficient to give the full scale deflection. Voltage across the galvanometer coil is given by IR 0.01 volt. Means 1 ampere current, milliampere current or 1.001 volt is sufficient to give the full scale deflection of this galvanometer. But what we are talking, we are converting this sensitive device galvanometer into measuring the large current of ammeter and large voltage in voltmeter. So we are converting. How to convert? How to measure this large current by the same galvanometer. Large current हमने directly इसमें अगर दे दिया तो coil burn out हो जाएगा. But if we connect a shunt, what is shunt? It's a very low resistance thick wire connected in parallel called shunt. तो मेन करंट शंट से पास हो जाए. शंट का रेजिस्टेंस क्या है? कम रेजिस्टेंस से ज्यादा करंट पास होगा. सो दिस इज द शंट हियर, वेरी थिक वायर, लो रेजिस्टेंस, ऑलमोस्ट ऑल द करंट इज पासिंग थ्रू द शंट, and small current of Ig passing through the coil, galvanometer coil. It is not burning. It can measure to very say large current. Let us say, taking by an example also, how to convert in the same galvanometer into ammeter by using the shunt. Suppose we are measuring 10 ampere current and galvanometer current is 1 milliampere, 0.001 ampere, and we are measuring 10. So 10,000 टाइम ज्यादा करंट दे रहा है, तो मान ले एक्स्ट्रा करंट को हम शंट से पास करा दें. I is the current, the main current, Ig is the galvanometer current, I minus Ig current passing the shunt. The value of here is S ohm. शंट की हमने S से डिनोट. So they are parallel. Galvanometer and the shunt, they are parallel. In parallel voltage होता है same. So this is the same voltage difference. Voltage I minus Ig into resistance S, शंट रेजिस्टेंस, Ig इंटू दी गैल्वानोमीटर रेजिस्टेंस. तो शंट रेजिस्टेंस की वैल्यू क्या मिल जाएगी? Igg अपॉन I माइनस Ig. पुटिंग द न्यूमेरिकल वैल्यू, फॉर एग्जांपल Ig इज 0.001 एम्पियर, G is 10 ohm, I minus Ig is 9.999. Approximately this is very small resistance connected as a shunt. The same galvanometer, now it can measure up to 10 ampere. Here, in the full scale deflection. Full scale deflection 10 की वजह से नहीं आ रहा, वो तो Ig की वजह से आ रहा. So this way, if we connect the shunt resistance of this value, the galvanometer convert into ammeter and measure up to 10 ampere current. So the range will be the 0 to 10 ampere of this ammeter. Shunted galvanometer is called ammeter. Now it can measure up to 10 ampere. Now conversion of galvanometer into voltmeter. Voltmeter पहले measure कर रहा था केवल 0.01 volt by the galvanometer current and galvanometer coil. अब measure करना हमको 100. ये again 10,000 टाइम ज्यादा हो गया. 10,000 टाइम ज्यादा हो रहा है. इसको हम 10,000 टाइम ज्यादा को अगर डायरेक्टली करेंगे तो जल जाएगा. तो coil galvanometer coil सीरीज हाई रेजिस्टेंस लगा देते हैं. So extra voltage is dropped in the series high resistance. Series current is same. पैरेलल में वोल्टेज सेम था, सीरीज में करंट सेम. तो आर की वैल्यू कैसे निकालेंगे? तो ड्रॉप 100 minus 0.01 is 99.99. So IR is voltage 99.99. R की वैल्यू 99.99 divided by IG 0.001 एम्पियर. 99990 है वो ओम्स रेजिस्टेंस सीरीज में लगाने से. अब ये रेंज हो गई हमारी अप टू 100 वोल्ट. तो ऐसे भी कर सकते हैं. टोटल वोल्टेज इज इक्वल टू आई एंड सीरीज में रेजिस्टेंस सेम ऐड हो जाएगा R प्लस जी. तो नाउ इस IG इज 0.001 एम्पियर, R प्लस जी की वैल्यू 10 है. सॉल्व करने के बाद अभी वो सेम वही बात है, चाहे पहले से हम वोल्टेज को माइनस कर लें चाहे डायरेक्टली निकाल लो. तो रेजिस्टेंस हमको मिल जाएगा वेरी हाई रेजिस्टेंस. सो बाय कनेक्टिंग द हाई रेजिस्टेंस इन सीरीज, दिस सेम galvanometer is converted into 0 to 100 volt range voltmeter.